Presenting Debugging Synergy Code in Visual Studio is Jeff Greene.
Right, so I'm going to start off by trying to get everyone on the same page in terms of some vocabulary and some features and functionality and what they're called and approximately how to get them. And then once I've done that, I'll dive into some more specific tips and tricks for traditional and .NET, and then I'll demo remote debugging in various scenarios. Right, so one of the most common things that we will end up talking to you about inside of Visual Studio when debugging things is what came out of the output window. So you can see that you get some kinds of output for build. That looks a little bit like a drop-down box, so you can get other things from it as well. So depending on what you're doing, that drop-down has more or less items in it. So when you're running, it'll be that debug selection there, and that's all the output that's coming out of your program in terms of things that are working or failing, informational messages, and things getting loaded, things exiting, exit statuses. A lot of helpful information will show up in the output window. So check there whenever you're wondering, how did this happen? So if your output window disappears because you've accidentally pressed the close button and you don't know how to get it back, you can press Control-Alt-O to bring it back, or you can also go through the menus, and that's View, and then Output Window is the button directly in that menu. So if you ever find yourself without one of these things that I'm showing you, just reference back to this PowerPoint and you'll have the answer quickly at hand. So the next one, it's very closely related to the output window. It's the immediate window. It's where you get to type things in to the debugger and have it respond to you directly. So I think everyone in this room is probably already used to the debugger doing it. That's sort of the normal mode of operation. This is kind of an escape hatch into that world, so that when mousing over stuff is not good enough, you can just go to the immediate window and throw commands in there and make it happen. So again, Control-Alt-I while you're debugging can bring this window back if you've lost it, or debug Windows immediate window while you're debugging will bring it back as well. So one thing I do want to call out, you'll notice in my screenshot example there is a bang in front of set uninitialized. So in order to differentiate different kinds of commands that are coming through in the broader Visual Studio ecosystem, in order to recognize that you just want to pass this command straight through to the debugger, we require that you prepend it with that bang. So exclamation point, whatever your command would have been, and it will run in this context. Locals. So we talk a lot about locals. Locals are, if your program is running and you've stopped somewhere, these are all of the values that are currently there. So your records, your local data statements, your globals, your commons, your class variables, they show up in a locals window. So they should be fully navigable for you. So you should be able to drill down into them, expand them, see what's inside of them, and basically just see what your app is doing at any given time. It only contains the local values for your current stack frame. A little bit later I will talk more about stack frames, so if that doesn't make sense, it will make more sense shortly. Everyone's code throws exceptions, has errors, I'm sure. I've definitely written my fair share of exceptions. So exception settings in traditional are pretty handy. They're a little bit different between traditional and .NET currently. That will be unified as we move forward into the product, but currently they are different. So if you want to control which exceptions get broken in the debugger, so basically if the exception is thrown, the debugger will stop at that moment and you can examine and try and figure out why did that exception get thrown from right here. So if you want to control which ones do and don't behave that way, it is in this project properties debug pane. So down at the bottom there, you can see break on unhandled exceptions and untrapped errors. So that basically stops at the moment the exception or error is triggered, or break on all caught exceptions and errors except. So if you put stuff in this list, we will not stop on that particular error or exception. Everything else, we will stop on. So imagine if your code commonly has record not found, it's not really an error. You don't want the debugger to stop just because there was a record not found. You would put that error code in this box, and then the debugger would just happily go about its business and not stop every time there was a record not found error thrown. So that text box accepts error numbers, so the error numbers that you guys are all used to, and then it also accepts fully qualified quoted exception names. So things like system.exception would be accepted in that list, and then if anyone throws something that is system.exception, we would not break at that thrown exception. .NET is a little bit different. It's basically checkboxes and a tree grid view thing, and you just toggle and say, yes, I want this to catch or stop when it's thrown, or no, I don't want it to stop when it's thrown. And if you lose this window, Control-Alt-E or debug Windows exception settings will get it back. In .NET, you can additionally put conditions on your individual exceptions to be handled. So if you want to catch all of the system.exceptions that get thrown from a particular DLL, this is where you would put that. And you can specify down to the actual module that you want to control whether you stop on it or not. Just a little bit more common vocab. So breakpoints. Who here has used a visual debugger before? Breakpoints are the best. They really are. I mean, locals is great, call stack is great. Breakpoints are pretty much your bread and butter when you're debugging. Without them, you would not get very far. So there's a window in Visual Studio that lets you see all of the breakpoints that you currently have set, lets you make new ones if you want to, and it lets you toggle them on and off, import them from a file or export them from a file, which turns out to actually be relatively handy in complicated debug scenarios. And it even, if you have like 100 breakpoints set, there's even a search in there. So you can go figure out, by name, what breakpoints do I have set. So there's a lot of functionality built into that breakpoints window. And if it disappears on you, you can bring it back with Control-Alt-B or debug Windows breakpoints. Also, breakpoints in Visual Studio are a little bit different than in the traditional debugger. So in the traditional debugger, you're probably used to mostly setting your breakpoints at a routine name. So in Visual Studio, you set breakpoints at a line number and file name, essentially. So from your perspective, you're just clicking in the editor and saying, set a breakpoint on this line in this current open file that I've got, and we translate that all under the hood and make it set breakpoints appropriately for you in the underlying debugger. Also, in .NET, you can put simple conditions in your breakpoints to basically say, when the code runs past this breakpoint, I only want to stop if this condition is true. So maybe you want to stop the 100th time through. You can put a counter on there that says, once I've hit this breakpoint 100 times, I actually want to stop in the debugger and do something with it. Or you could say, if this variable is true, I want to stop in the debugger and do something with it. So that's pretty useful, but it is .NET specific currently. So once you're broken in the debugger, you can move around, right? So you can step over something, which is F10, and that's going to run the debugger until we get to the next line in the current call frame. So if you are stopped on an X call and you press F10 to step over, it will step past that call, and you will stop immediately after that X call and be able to do whatever it was that you wanted to do. You can also step in. So again, if you're on that line with the X call and you press F11 to step in, it's going to go into that X call, and you're going to be able to debug inside that X call now. So F11 and F10 work very similar if there's not a call on the line that you're currently running, right? It runs to the immediate next step regardless of where it is. So if it's just A equals B, B equals C, right? If you're on that first line and you press F11, it doesn't really have anywhere to go other than just the next line. So it's a small distinction. Step out is Shift F11, and if you are inside of that X call, it will get you outside of that X call. So these are all functions and features that are built into the traditional debugger that you guys are used to, but not everyone knows about these features, and I'm just trying to map them into sort of Visual Studio terminology for you. Call stacks. Call stacks are really, really nice when exceptions get thrown, right? How did I get here? Why does the world look the way that it does? The call stack lets you move up and down the frame list, look at all of the local variables at that particular given frame, and try and figure out, like, why did I get here? What went wrong? So as you navigate in that call stack, it will move you in the editor to that frame location. So even up farther in the call stack, if you double click on it, your editor will move to where execution currently is in the context of that routine. So if you're up one, you would be at that xcall line that got you to where you're at. Hover over, also very helpful. If you can't see something directly in the locals, or you just want to know, hey, I've got this named thing sitting here, I want to know what the current value of it is, you can just put your mouse over it, and you'll get a helpful pop-up from the debugger, and it will tell you the current value of that thing. So this only works for stuff that exists at runtime. So if you hover over a define, for example, we will not know what that is. So make sure whatever you're hovering over is something that actually exists as that named thing at runtime, and it should give you back values and let you drill into specifics. Also, .NET specifically, you can change the values. So I could click inside of that string literal that says hello there, and I could change it to goodbye or whatever it was that I wanted, and then resume execution, and the program would have that data. This is actually a pretty useful feature if you haven't been able to use it before. If your code is running through and you see that it's not going to go into the if statement that you want it to go into, you just change the value and let it run, and it will go in there, and everyone's happy, and you debug your scenario. So, going to talk about some traditional specific stuff now, kind of dig into the meatier bit of this presentation, I guess. So first off, we have immediate window goodies. So remember back to that immediate window that I showed you earlier in the presentation. These are some things that you probably want to use in that window. So set uninitialized will break in the debugger if we ever detect that you are using an uninitialized variable. So if you have something on the stack and you haven't given it a value, what is the value of that thing on the stack? Who knows, right? It's probably not going to work out really well for your program if you're accessing stuff that no one knows what the value of it is. That value could change every time you run your program. So uninitialized variables are bad stuff. So set uninitialized will have the debugger tell you when you're doing something with them. Set watch lets you break in the debugger when the value of a variable changes. I don't know how many people actually already use this. Does anyone already use set watch in the traditional debugger? Yeah, so for anyone that doesn't use it, obviously it's pretty helpful to know when the value of something changes and have the debugger stop there, right? So inside of Visual Studio, you can just say bang set watch, and it will work the same way that it always did. So referencing back to that previous slide where you can just mouse over things in .NET and change the value of something, the way to do it in traditional is with bang deposit, and you can change the value of a variable just like you could in the traditional debugger as well. So it's a little bit more effort. That will probably change over time as we get more features and functionality integrated into the product, but right now the immediate window is your escape hatch into that direct command world. So one more thing in here is show classes. So this has got a bunch of sub-functionality on it. You can either say show classes all, or show classes references, or show classes lines, or show classes scope. And it will tell you things like where are all the live instances of this class. So if you've got OO code and you're wondering who has made these copies, who has created instances of my object in my currently running program, show classes is where you go to get that information. It'll also tell you where those things were created. So in addition to knowing who's keeping them alive, who's currently using them, you can find out who made them. And that tends to be a pretty useful functionality when you're worried about running out of memory or where did this thing go? I don't know why it's gone. There are some very helpful error messages that show up in the output window while you're debugging. One of them that's relatively recent is pushing past integer or object descriptors of declared some kind of argument in a routine, some kind of routine at a particular line number. So if you're passing alpha data, so ABC, into something that takes a decimal, there's a problem with that, right? How do you add ABC plus 1, 2, 3? Things go very, very wrong when that happens. So when you're running under the debugger, we will detect that at runtime and see that there is in fact alpha data in there and it's being passed to something that's decimal or integer into one of the other types as well. And we will print that out in the output window. So we're not changing any of the actual behavior present in your program. We're just printing this helpful error message in the output window, and your program will continue operating exactly the way it was before. So watch for those in the output window. If you're having weird, undefined kinds of behavior and you're not seeing uninitialized values, that is another big source of I don't know what's going on. The other ones are relatively straightforward. It's like the watch point that you set has gone away, or the watch point on an object doesn't exist anymore, or the handle has been deleted. Those sorts of things are pretty straightforward. Or the use of uninitialized memory, incorrect paths, or duplicate common static records or GDSs. So helpful error messages, always be on the lookout for those when debugging inside of Visual Studio because they will pop up and save you a lot of time. If you're wondering why the debugger didn't start, sometimes you press F5, nothing happens. Usually, the source of information there is going to be in the output window. If on startup, for example, you're missing an ELB that you referenced, so that ELB doesn't exist on disk anywhere, an error is going to happen, right? And depending on your exception settings and how early that failure occurred, the only indication of that you're going to see is going to be in the output window. So pressed F5, nothing happened, go look in the output window. It'll probably tell you what happened. Also, we are now enforcing a minimum debugger protocol version, and we let you know in the output window what you're actually debugging. So if you want to use the fancy new features of the Visual Debugger in Visual Studio, make sure that you are on a latest runtime. And if you're not on a latest runtime for your developer environment, it will tell you in the output window what it thinks you're currently running. And if that version is too low, it will tell you, please upgrade. Now, there is actually a bug. It is possible for you to get that error message in the build that is currently out there, even though you're running the most recent DBR. So if you get that and say to yourself, I think it's lying, it is. It will be fixed very shortly and will not be an issue going forward. But for right now, if you see that message, it may be less helpful than it should be. So when that exception does get thrown, what do you do? How do I know what the exception was? So inside of your locals window, you're going to see this thing called $exception. It'll just be like any other local, and it will tell you, here's the text of what was thrown, or here are the members of the exception object that's been thrown, or here's the runtime error, and we've mapped that runtime error number into whatever the text is that's associated with that runtime error. So once you've got that exception, what do? So you've got stack traces potentially in the exception object. You've got the call stack window that's available to you, so you can try and figure out, how did I get here? What was the state of the world in the routine that called me? And also in .NET, if things are really not going well and you need to hand off to some other developer somewhere, or it's someone else's problem and you want to hand it off to them one way or another, you can just dump the whole process. So under that debug menu entry, you can say debug save dump as, and it will dump memory for the entire process, and you can hand that off to someone else and say, here, this is your problem, you debug it. And they open it in Visual Studio, and they can see all the locals, and they can move up and down the call stack and figure out what happened, and they can go fix it themselves. So, XF Server Plus. I hear debugging it is hard. Who here has ever done remote debugging for XF Server Plus? Was it a great experience? Leave your hand up if it was a great experience. Right? I'm not sure that the hands are going to go up for that second one. So who would be excited to not have that experience anymore and get to debug their stuff way easier? Yes, so we have docs for this. This shipped in 10.3.3c. So I've put our very long doc URL there in the presentation, just in case later on you want to go click on it and read our docs. But they are definitely available. So I think it is demo time. And assuming the demo gods are with me, this will be a favorable experience for all involved. Right, so I have a WinForms application here. It doesn't do very much. It's just a WinForm. That's the WinForm itself. So this happens to be written in Synergy.net, but it's talking to some Synergy code that is in XF Server Plus, and that is the syncode.dbl thing here. So before I've started anything, I just set a breakpoint inside syncode, the file. I don't actually have a project for syncode. That was built by something else. There's no relationship between my project that I currently have open and XF Server Plus. I have a client app right here, right now. The only thing that I have a project for is the client app in .NET. So I'm going to run my client app. Really simple, right? Doesn't do very much. Has a nice click me button here. So when I click this button, it's going to go make a XF Server Plus call, and ideally we're going to debug into that XF Server Plus call after I've attached to it. So that just spun up XF Server Plus when I clicked on it. So now I'm going to go attach to process. I see my transport is already set up, which is handy. Usually it won't be, so you have to change this to say Synergy Telnet based. And I know that I'm running on localhost. And I set it up as port 4444. Pressed enter twice. Ideally, I get this screen. So it's either going to show me this screen right now that you're seeing before you, which is frame not in module, not really helpful. But if I were to go look at my call stack, it would say main $xfpl. That's not my code. That's XF Server Plus, some underlying bits that you guys really don't care about. So when you get this pop-up, don't worry about it. Just press F5. And now I've broken at my actual code inside of syncode.dbl. So now I'm in here. You can still see in that call stack that main $xfpl is still there. It's running. It's the infrastructure that runs XF Server Plus. But you can see that I'm in here, and I can step around and do stuff. And it works fairly well. So if I let that continue, my WinForms thing finished. It's not a great piece of WinForms. It didn't really tell me anything, but trust me, it really did run. And the specifics of how to actually set up remote debugging are available at that web docs link that's earlier in the presentation. So more remote debugging. So that was remote debugging essentially, right? So XF Server Plus is client-server apps. So you can imagine your XF Server Plus server is probably running on a different machine. Maybe it's running on your machine, but it doesn't really make a difference. It's still the same operations. Instead of typing in localhost, you would type in whatever that machine name is and the port number. So it's not too different. But I'm gonna show you guys, hopefully, remote debugging on Linux and remote debugging on VMS. So I have here, and this is a project, but it didn't need to be a project. It could have just been a source file that's open in the editor. But this is makeshare.dbl. So I've built this over on a Linux machine back at the office. And this is in the shipping product. So this is in 10.3.3c. So that's what I have set up here. So if I want to remote debug this program that's running over on a Linux machine, all I have to do, I've built it on that Linux machine. I could have built it anywhere. It doesn't really matter where I built it, but I've built it on that Linux machine. So the way that I start it is with this dbr-dv-rd and the port number and then the program name. So it's not that odd in terms of how you would actually start remote debugging. I've specifically put dv here just because I'm turning on Visual Studio mode. It makes things a little bit simpler. It's not actually a requirement, but for the purposes of this demo, it makes things a little bit simpler for me. Right, so I'm going to run this DBR program, makeshare. And it's going to sit there and hang, waiting for me to attach with the debugger. And this particular Linux machine is called Mo64. And it's back at the office. And it's on port 4444. Press enter twice. And receive debugging. Right, so hopefully you can see it. There's that yellow arrow over there that's saying that's where I'm currently at. So hopefully you can see there that remote debugging in Visual Studio is actually pretty easy, certainly compared to where things were before. The tooling is available and readily accessible. So the other thing that I had on my list here of showing debugging was OpenVMS. So this program is actually a little bit more interesting in VMS because it is a VMS program. And in fact, when I run it on Linux, all it does is say, you can't run this program on Linux. It only works on VMS. So if I kick back over to my telnet and switch over to the VMS machine that's at work, I've already set up, I have basically a batch file that is just going to run this program. And there's no dbr.exe on VMS, so the ways that you actually kick off remote debugging on VMS are a little bit different. But we do dock those, again, at that remote debugging link. So I'm going to run this thing. Again, it's waiting for me. I should be able to attach with telnet to VMSIT. And that program is running on VMS. I'm debugging it from Visual Studio. And you can see that I have locals, which is good. You can see that I can step around and do all the sorts of things that I could do if I was running this locally on my machine on Windows. Hopefully that makes life a fair bit easier for people who want to debug their programs on operating systems that don't start with a W. I also want to make just a quick reminder, I'm not going to demo it, but you can do this same stuff from Windows to Windows. So if you're saying to yourself right now, that's great, thanks for helping out those Linux customers and VMS customers, but what about me? If you run that exact same command prompt that you saw on Linux, on Windows, it will do the exact same thing. So dbr, -rd, port number, and your dbr name. It will start up in debug mode and wait for you to attach to it in Visual Studio, and then it will go about its business of doing whatever it is that you wanted it to do. One quick note about remote debugging is if the paths on the remote system don't match exactly what's on Windows, you will get pop-ups from Visual Studio saying, would you please tell me where this file is? So it'll show you the original path, and it'll give you a chance to say, this is where that file is. So when you get that, tell it where it is, and everything will work from then on. On VMS, we actually strip the path entirely, and all you're left with is the file name currently. So all you have to do is have that file currently open in the editor, and Visual Studio will automatically choose that file named tab, and everything will just work again. So this is potentially a problem for you if you have the same name file over and over and over and over, right? That might get a little bit strange trying to deal with. So on VMS, there's not a way to disambiguate those currently, but on Linux and Windows, again, you'll get that pop-up each time, and it will offer to map that particular source file over for you. So, debugging without a project. Debugging without a project is remote debug on Windows. That's really all you're doing. So, dbr, -rd, random port number, dbr name. It's that simple. So it's the same set of steps that you just saw me go through in order to debug on Linux and VMS. It's just you're typing in localhost instead of some other machine name. So pretty simple. So now a little bit of extra goodies for people who are debugging in .NET specifically. So one of the things that not a whole lot of people back at the office in Synergex necessarily knew about until recently was a handy feature called step into specific. So if I have a method call, function call, whatever, and there's dozens of calls in the argument list for that. So in order to produce argument 1, it's calling a method or a property or something like that. In order to produce the value for argument 2, it's calling a method, property, whatever. And it's all on one line. How do I step into the right one? Gets a little bit iffy. I don't want to step into 18 things and have to step back out of them. So they have this handy thing in here called step into specific. So if you're stopped on a line that has multiple method calls on it, you can just right-click say step into specific, it will show you all of the method calls, and it lets you choose which one you actually want to step into. So you don't have to go in and out and in and out and in and out all over the place in your call stack. It just makes life a little bit easier. So the next one is turned on by default. Sometimes you want it on by default, sometimes you don't. So just my code basically says that if I didn't build this, please do not surface exceptions that are thrown from here, because I probably don't know anything about them and I don't care. If I'm trying to step over something or into something and I have just my code turned on and I'm stepping into something that's not mine, it will skip over it because I'm saying, please don't debug anything that's not my code. Sometimes you want to know exactly when an exception was thrown, and turning on just my code will mask that, right? It will not tell you exactly when that exception was thrown. It will tell you when the exception made it to your code. So if you're having a hard time figuring out where an exception came from in .NET, turn off just my code. Set that break on exception thrown, and you will end up where the exception was actually thrown instead of the first place it made it to you. And my last good odds and ends here is in .NET, you can write custom debug visualizers. So if you have a complicated object and you want to make sure that when you look at that at a glance in the debugger in a list of 1,000 objects, it's showing you exactly what you want to know without having to drill into it like 40 different layers worth of member variables, you can build your own custom debug visualizer, which will run inside of Visual Studio. And they're very easy to create, and I've provided a link to the Microsoft documentation for how to create those things. So you saw remote debugging on traditional side of things. You can also do remote debugging to Windows in .NET. So we have docs again for this, and Microsoft has some docs for this. But the first thing that you have to do is you have to install remote debug tools on the target machine. So that's running out there, and that gives you something to connect to. And you also have to install Synergy remote debugging tools on the target machine so that you get Synergex-specific functionality when you're debugging against that machine. So you run remote debug tools on the target machine and attach from Visual Studio, very much like what you saw when I was debugging traditional. It's the same thing, except instead of saying connect over Synergy Telnet, you're connecting with the default connection type and giving it just the machine name. And a quick reminder to everyone, when you are debugging Android and iOS, that is always remote debugging. If you're debugging to an emulator, that's a different machine. It's remote debugging. If you're debugging on a piece of physical hardware, that's remote debugging. All of these things hold true all of the time. When you are debugging on Android and iOS, just make sure that when you get the pop-up in the IDE that says, please copy this Synergy file into this folder in order to enable debugging, that you follow that prompt and put that DLL in place. Otherwise, you will not be running a Synergy debugger. You'll just be running a plain C# debugger that sort of works some of the times with the code that you've written. With that, who has the first question?
What kind of privileges need on the remote machine that you're going to debug? On a Linux box, let's say.
It's just Telnet, right? If you're able to run the program and you're able to see Telnet through your firewall, there's not a difference in permissions. It's just, it's running in our process. It's not like a system level debugger.
What happens when you're debugging a traditional Synergy application and you step on a line that does a .NET callback?
So if you're doing .NET interop and you step on a line that's going to take you out into .NET, you're basically leaving us. And that's okay. There are ways to to give you a cohesive debug experience in that scenario. Basically, the debugger on this side is going to behave like you're just running code, right? It's not going to break in the C# stuff. It doesn't understand the C# stuff. It just understands traditional Synergy. Depending on how you started that program, if you're running it in remote debug, you can actually attach essentially a second time to that process with a .NET debugger, but you have to be very careful with the sorts of things that you ask it to do while you have two debuggers running on it. So it's really, really easy to hang up Visual Studio in that scenario. Basically, if you tell one part of the process to stop responding and the other part of the process says, I need to know something, there's a conflict, right? Everything will fall over at that point. But if you're just talking about, I want to step and make it into the other side, you can attach with both debuggers, as long as you're doing remote debugging rather than F5. You should be able to do that. Right, everything that I just described is only useful to you on 10.3.3c. There were issues in the product previously that wouldn't let you step into the Synergy on the other side, potentially, of that call.
Would it be possible to remote connect through a SSH port?
There's no technical impediment to that other than DBR only understands Telnet. So if you do SSH tunneling, that would be transparent to me. I wouldn't have to know that you were using SSH.
Okay.
If that more or less makes sense.
And would it be possible, is there any plans to allow us to see variables higher up in the call stack than your current frame?
Would it be possible to see variables higher up in the call stack? So if you go to that call stack window and you click on the call frame you want to get variables from, you will have access to all of the locals at that point as though your code were right there.
Right, okay, thanks.
Do you have to have 10.3.3c on both the server and the debugger side? Like on VMS running the executable, does that have to be 10.3.3c as well?
So the VMS machine would need to be 10.3.3c.
It would, okay.
Yes. And generally speaking, the debugger is moving very, 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 very quickly. So if you're trying to do debugging stuff, make sure that you are using the latest runtime to do it. Things like my presentation falling over there in the middle, those things go away really fast. So you just want to make sure that you're on the latest version when you're doing debug work. You can deploy to whatever environment you want to, but when you're debugging, try and stay very up to date.
On the remote application that's running, does that have to be built under debug, or could you debug to a production server and just start the task up in a different way?
So that's actually a really solid question because I didn't specify how I built these programs. The programs that I built for the purposes of the demo were all built -D. They were all linked -D. So that gives you the best debugging experience that you can get. If you don't do that, you will generally speaking not have access to local variables, but what you do have access to is still parameters, and you can still set some breakpoints, although they may not be as good, as in only certain places in the routine will necessarily accept that breakpoint. But basically, yes, you can get some debugger functionality if you have not built debug.
No, that's okay. I mean, then that just means you build a version of it under debug and throw it onto the live site and try it there then under that.
Yeah, that's probably the fastest way to solve problems. All right.
Thanks, Jeff.